Tack. I'll switch to English because there are some English-speaking persons there. Indra is a technology group company. In Norway, we are approximately 200 people. In global, we are some 43,000. So we are proud to actually have center of excellence of some of the innovations from Norway, and we are also connected to the universities, both in southeast of Norway and the Technical University in Trondheim. We've been looking at the applications you can see visualized here, which then are the dirty, dull, and dangerous operations. Now, they are single operations, but eventually, and from now on, they will actually start to merge, and they will start to actually be within the same ecosystem, which is then a UTM system. Now, we've been working to see how we can transfer our ATM core technology, from which Indra originates, and the competence and some of the technologies into UTM or support to UTM. We've made an app just to communicate with some of the drone environment, because this is millennium kind of thoughts, need another digitalized structure, apart from the ATM, which is a little bit more traditional, one could say. Now, we're also looking at the constraints and see that there is a change of information from search and rescue and other platforms into this platform. Not necessarily a closed product, but an open structure. Now, then it's getting interesting to see it could be like a cell phone where you can actually make a phone call, but the actually product is data within. So the carrier is then the backbone, but all the products will evolve. So a few years ago, maybe 20 years ago or something, we could make a phone call, but we couldn't use all the apps. Now we can actually use it for calling. Still, it's possible, but it's not what we do. We use Attendify, we use the apps and other stuff to do. And we see that there's a multimodal kind of approach to this, and we're very curious to see how we can exploit all the sensors and the data and how that actually will evolve on this one. We then have dynamic, okay, things that change, you'll have incidents, and this will affect the ecosystem in total. Our goal, strategic-wise, is that the UTM side will be just as safe as demand aviation, but with other technologies and a different approach. In order to do this, we think that the divide of the airspace would need to have some kind of corridors, some kind of dedicated airspace for some applications, and there will be some kind of regulation dividing the corridors, and there will be a definition of the human role in this loop. So we're connected to the academic society to see how we can define the human role in a automatic or automized kind of environment, which this most likely will be. We'll have a less significant operator, but they will operate maybe a set of services. Now, this brings us to conformance monitoring, which is actually, we use our navigational support, we use our surveillance to support a safe drone operation. We'll know exactly where it is with a high integrity, meaning that the probability of any incident to occur which could affect third-party risk is reduced. This could be an ADS-B, this could be a GBAS kind of solution, which you normally would recognize as an RTK from the commercial side of drones. But it could also be the 4 or 5G, but that won't necessarily be enough with one, so we're making now a matrix of these support elements to then qualify and certify different technologies together in order to obtain this safety, and then we can move the drone operations and various UAS operations into our proximity, into the urban areas and similar. And we also looking at the capacity of this, versus the number of sensors and the information. And that moves us towards the optimization of this. We're quite reluctant in using autonomy because autonomy is very difficult to define. But if we use a capacity management with software layers, we can then isolate some of the layers and we can have a automatic function, reducing the labor cost of operating, and the return on investments for UAS operations will be significantly improved. But there will be several steps on the way of doing this, and we're just actually touching the base of it. There will be some legal constraints because we have to prove this. Coming from the navigational side, sometimes it takes 4 or 5 years to actually qualify and certify a technology. Whether or not that will be the case there, I don't think so, but we'll have to prove it somehow. Now, we're also looking at how this could come together, and the developments takes a little bit longer time than what we've expected. We see that now they're improving the different services available, but it's improving. Along the way, we needed to actually deploy some of this experimental research. So we teamed up with the universities, we teamed up with Andøya Space Center, and we deployed a permanent installation at Andøya to look into how we can actually give information and have dynamic operation in search and rescue. So we can actually give information both to the search and rescue and to the drone operators to actually see that it's not dangerous. We just need to have a controlled environment. And then from this point on, we have dynamic, rather limited number. We can then actually scale it out, include the corridors, include the optimization, and then have several ecosystems working together. So we're going to deploy a little bit more along the way, but I'll show you a little video of how we've done it here. This is a permanent installation, and we're going to use more technology as it actually is available. Both the 5G, the slicing, that's not common yet. It's improving, but we're not there yet. We don't know exactly how it's going to be. We also need some GPS-independent kind of solution. That's a little bit tricky, how we're going to do that. And especially when moving towards application which involves transport of people, will need some kind of very high integrity, and which will be GPS non-dependent. So let's see if I can get the video running.
The efficiency and flexibility of drones offers significant benefits, but disruptions caused by drones flying near airports can affect thousands of passengers, and conflicts between drones and conventional air traffic can occur also in more remote locations. The island of Andøya in Norway, 2 degrees north of the Arctic Circle, is home to the Andøya Space Center, a service provider for sounding rocket, balloon, and scientific ground-based instrumentation communities, and highly complex drone missions. Andøya's airport lies close to the Space Center. To ensure that their drone operations can be carried safely alongside manned air traffic, Andøya Space Center contacted Indra.
We provide solutions that ensure safe traffic in some of the busiest airspaces in the world, such as London Heathrow and Dubai International. We also offer technologies to manage unmanned air traffic, and in this project we merged the two.
Andøya Space Center needed a surveillance system to monitor manned and unmanned air traffic. Indra supplied a processing and display system based on ADS-B that detects and displays all air traffic movements on a single integrated screen. The ADS-B antenna, which was placed at the top of nearby Ramnen Mountain, covers an area of 150 nautical miles, from south of the Lofoten Islands up to the city of Tromsø.
This system gives us the possibility to conduct testings with more complex scenarios than before. This system enables us to have several drones airborne at the same time and still having the position of the drones, the trajectory of flight, where they will be in a few minutes and so on. We would like to have it fully integrated with the range control and range safety system, but it also gives us the possibility of starting the tests of the concept of U-space with dynamical airspace and integration with manned aircraft.
The system at Andøya is based on the same technology that clients use worldwide to manage traffic at airports. The project demonstrates that we are capable of tracking manned and unmanned air traffic and display the information on a single screen. We could easily include more advanced functionality used at airports, such as security alerts and flight plans.
Indra's solution has given Andøya Space Centre improved situational awareness, allowing drones and conventional aircraft to operate safely in the same airspace.
So this is basically what we've set up at the moment. We're using now the sensor fusion engine we have at an airport such as Dubai. You can imagine the number of transaction and information exchange which is available at such an airport. We're using the same engine for kind of transferring it to a UTM society, and see, instead of like a baggage handling or a security control, we're then including the sensors to see how we can utilize the sensor engine on this one and the fusion. And this will give us huge opportunities. I don't think we see the full range of the UTM. We don't know exactly what it is. We have some constraints with some call it strategic deconfliction. We will use our safety nets, which is the actually detection of possible risk, to actually give awareness of that there is a risk which could occur either in a period of time or in a region. We will then move now to the next phase, where we are developing this safety nets into more of a intervention, where we actually change the system into intervening with the pilot in order to avoid the risk, and that is connected then to the optimization. So this comes together. There will be a few years before we see this deployed. This solution will be, we have in Andøya will be then expanded the next 2 or 3 years. We've decided to run the development up there the next 3 years at least. By that time, we will have the corridors, we will have the automatic flights, and we will have some of the support elements. But then to see the full range of the possibilities, it's difficult to say how this will evolve, because then you have the constraints from the authorities, how we're going to use the airspace. And that brings me into, we need to think a little bit more closely on the privacy, what we actually want to do with the airspace. In our proximity in urban areas, we want to explore the medical supplies maybe. We want to explore some critical applications, but it's not likely to see any extreme density of drones in urban areas, because our privacy will prevent that from happening, most likely. So there will be more of special application. Now we have 4 or 5, and I think we'll see more a segment by segment rolled out in the market, which will then be fused into these ecosystems. And it's going to be interesting to see also the support technologies, if we're going to use more of a AI on the navigational side, and how that actually could be certified, because that's a little bit of a gray area at the moment. From the academic side, they're using the AI on the navigation from images, but then to transfer this into airspace industry, it's a little bit different story. It's not straightforward. And also to actually see what kind of products we can have for this, which is then a sustainable piece. So that's pretty much where we're at the moment. Thank you.